So we apply the factor by grouping strategy whenever we have more than 3. We can't really use we can't use grouping with trinomials, and we can't use grouping with binomials. So typically factor by grouping only happens when you have 4 terms, because then you can actually group your 4 terms into smaller groups of 2. All right. And so I hope that you'll find this fairly easy, fairly simple. So in example 1, right, that's basically the first set of instructions. It's to split into 2 groups. Where do you split it? Typically, you'll split it right down the middle after the second term. So a to the third plus a squared, right after that ends, this is where it gets split. So notice how the sign, the positive, that belongs to the a, which is the third term, right? That lets you know that that a is a positive value, all right? So that's where you want to split it. You don't want to split here, because there will be times when that sign will not be positive, it'll be negative, which means that the term is a negative. So you don't want to split it after the sign, you want to split it before the sign. All right, so we split it, where we have 4 terms, we split them into 2 groups of 2. Okay. All right, so now what happens next? Well, we're going to work strictly with a to the third plus a squared. And what we're going to do is we're going to find GCF. So part 2 is to find GCF of group 1. All right, you have a to the third plus a squared. What is the GCF between just the first 2 terms? Yeah, it's a squared, right? So we're going to factor out a squared just from the first 2 terms. So what are we left with? What's going to go inside those parentheses if we factor out a squared? A and plus 1, right? So a plus 1 is what's left over. Okay, now we look to second group, all right? We're also then going to find the GCF of group 2. Now, sometimes when you look at the second group, you might not find a GCF, all right? You might not see like, hey, we can both divide them by this number or by this variable, but they still have something in common. What is that one thing that they can still be factored by? That's right. They can still at least be factored by the number 1, all right? So you need to factor out something, even if what you factor out is a 1. So we're going to factor out positive 1. And although that doesn't change anything, right, we factored out positive 1. So it's like taking a, dividing it by positive 1, you still have a. You take positive 1, you divide it by positive 1, it's still positive 1. All right. Now, we arrive at this point where we have a squared times a plus 1 plus 1 times a plus 1. Here's how you know that you're on the right track when you did factor by grouping. Whatever is inside those parentheses should be exactly the same. All right, that's how you know that you're on the right track. If you do GCF for both groups and whatever is left in those parentheses is not identical, then maybe you didn't factor the GCF, you made a mistake, maybe you didn't factor out a negative. There are a lot of different reasons, but your goal is whatever's inside my parentheses, it should match exactly. All right, so I'm going to just rewrite it, okay, just for the sake of making it look a little cleaner. So I have a squared times a plus 1 times a plus 1. All right. So now technically what I have are 2 terms. I have 2 separate terms. Here's term number 1. Here's term number 2. We're going to do GCF one more time. What is it that both of those terms have in common? There's more than that. It's not just one. Don't they both have a plus 1? Would you agree that they both have the term a plus 1? Right. So then couldn't we divide both terms by a plus 1? Couldn't we factor that out from both of them? Yeah, it's tricky to look at, right? It's tricky to look at because they're in parentheses. But remember, everything underlined in green is one term. Everything underlined in blue is one term. But what do they both share? They both share this piece right here. They have this in common. So guess what? We're going to do one more GCF. All right. So that GCF then becomes a plus 1. And guess what? I have some leftovers here. A squared and positive 1. So guess what? Those terms get put into a new factor, a squared plus 1. All right. So then this ends up being my final factored form for the original polynomial. All right. Any questions there? Let me show you another quick way that which this could be done. We can take the full polynomial and just throw it right into a box. All right. So we're going to take all 4 terms and we're going to plug them into this box. All right. A to the third, a squared, a, and 1. And guess what? We're going to do GCF across each row, and we're going to do GCF across each column. All right. Let's see if we arrive at the same polynomial that we got using the other method. All right. So if I have a to the third and a squared, what's the GCF for that first row? That's right. It's a squared. All right. Take a look at a and positive 1. What's the GCF of the bottom row? What's the GCF here? Yeah, it's just positive 1. Now take a look at the first column, a to the third and a. What's the GCF between those two? Yeah, it's just a. And then take a look at what is the GCF between a squared and 1. Yeah, it's just 1. So take a look. You have your factors on the outside of the boxes, right? So if I look at these 2 terms, a squared and 1, that's my first term, a squared and 1. So a squared plus 1. What's the other factor going to be? Whatever is on the top. So I end up with a plus 1. Yes. So if you write it a squared plus 1 times a plus 1, it's still the same as a plus 1 times a squared plus 1, right? Remember, commutative property of multiplication allows you to take the factors and move them around as long as the factor is completely moved around, right? You're moving the whole parentheses around. So you see that they're the same. And you get to decide which method you're more comfortable with. So box method kind of comes back. And then we can also try the other method that I showed you from before. All right. In the first method, we split them up into groups. You find GCF once, then you find GCF again. In box method, you basically put all 4 terms in order, top, top, bottom, bottom, and then you just GCF each row and each column. Okay. And then there was a question before, why can't you just add the a and make it a to the 6th plus 1? The reason why is because a to the third and a squared are not like terms, and a squared and a are not like terms either. In order to be a like term, you need to be to the same power. So when you're adding, if they're not the same power, they're not like terms. Okay, so that's why we can't come back. That's why we can't collect all the a's together. If we were multiplying a to the third times a squared times a, then you could add the powers and you get a to the 6th. But when you're adding, remember, you have to collect like terms, and they're not like terms if the powers don't match. Okay. So there's a reason why it's shown as 4 separate terms. All right. I hope that makes sense. Hope that answers your question. All right. So any questions so far? Which method do you guys kind of like more at this point? Method 1, method 2, traditional, or box? Okay, some of you like first method, some of you like box. That's fine, right? So you decide which one works best for you because they both work, right? They both work. So that's the good thing. All right, let's move on to example number 2. Okay. I'm going to go traditional method for one of them, then I'll jump back to box method, and I'll kind of alternate. All right, so I have 4 terms, right? Again, these are not like terms. They can't be combined. Before I begin, do I have a GCF for all 4? Is there something all 4 have in common before I do my split? No, right? 2, 4, and 8 could be divided by 2, but not 3, right? So no GCF between all 4. So we're going to go ahead and jump into the grouping. Split your 4-term polynomial down the middle, and let's take a look at what the GCF would be of your first 2 terms. What would that be? Yeah, 3x squared. Good. So if we factor out 3x squared, what are we left with inside of the parentheses? X and positive 2. That's correct. Okay. So now let's go over to the other side. What is the GCF of the second 2 terms? Yeah, 4, right? It's a positive 4 that we can factor out. And what is left over inside those parentheses? X, right? We divide 4x by 4, we get x. Divide 8 by 4, we get positive 2. All right, how do you know you're on the right track? Yeah, because the x plus 2 matches, right? Whatever's inside the parentheses will match. Right? Whatever's on the outside of the parentheses, that doesn't have to match. That's fine. But the inside should match. All right, so now you have a new GCF. What is that new GCF? Yeah, the new GCF is x plus 2. So then the leftovers, they get plugged into the last set of parentheses. All right, so what should my second factor, what should it say? Correct, right? Here's one leftover. Here's the other leftover. This is why I used the plus 4, even though I factored out a positive, right? Because I want to make it very obvious that when I drop my terms into the new factor, I know what the symbol should be in between, that it should be a plus, right? Because if, let's say I didn't have the plus and I just had 4, you might be left wondering, like, what should I use? Correct, right? And you might make the mistake of sometimes multiplying. Thank you for sharing that, right? Because you're kind of left without a symbol and you're wondering, what should I use? So even though it's kind of redundant, you're factoring out a positive 4. We usually don't write the positive if we use a positive 4, but I think it's helpful because it reminds you that there should be a positive in between the 2 terms. Okay, so there it is. Any questions on number 2? All right, let's keep moving. Let's go to number 3. All right, number 3, let's set it up in a box method. All right, so all right, here we go, box. 35xy, negative 5x, right? So include that negative. Negative 56y, and positive 8. All right, so let's go ahead and go through it. What would be the GCF of the top row? Yeah, we have 5x, right? Both 35 and 5 divisible by 5. They both have x in common, so 5x is my GCF. Okay, let's see if you guys remember this from last time. Bottom row, negative 56y, positive 8. Yeah, why do we factor out a negative? Which one is considered my leading term? Yeah, exactly. The leading term for the bottom row is negative 56y, right? So it would be the same thing as if we did traditional method and we cut the group after 5x, right? It starts with a negative 56. So when I think of GCF, I have to think of negative 56 is my leading term. So if it's a leading term that's negative, you want to factor out a negative. So 56 and 8 are both divisible by 8, but you want to factor out a negative because the 56 is your leading factor. Or I'm sorry, your leading term. Okay, so far so good. All right, let's take a look at the column number 1 here. 35xy and negative 56y. What can they both be divided by? Yes, 7, right? 7. In this case, that leading term is 35xy, right? 35xy is my leading term, so I don't need to divide a negative. Okay, what else do they have in common? Yeah, the 7y, right? The variable too. Good. And then lastly, negative 5x and 8. What do you think? Negative 1 or negative 1x? only the negative 5 has an x, so I can't factor out x from both of them. So it would only be a negative 1. Once again, we're going to treat this as negative 5 is on the top, so that's the leading term. So therefore, because the 5 is negative, we want to factor out a negative. They don't have anything else in common besides 1, so that's why we factored out the 1. All right, so therefore we have our two factors. We have 5x minus 8 as my first factor, and then I also have 7y minus 1 as my second factor. What could you do if you really wanted to check that you did this right? You can multiply through, right? Distributive property, FOIL, and then make sure that when you do completely FOIL this out, you could then make sure that you got the correct original polynomial. You could also try using the traditional method, right? So you could do both ways just to double check your work. Right. So it's always nice when there's two ways to do something correctly. All right. Any questions so far? All right, cool. Let's keep going. All right, let's try traditional method this time. All right, let's split this up. 2 terms after the second term, split it. What is a GCF of our first 2 terms here? Yeah, it looks like they can both be divided by 3. They both have a in common, and the lowest power they share is a squared. So we can factor out 3a squared. What's left? For z, yeah, 4a, and then minus 3. Okay. And now group number 2, what could be factored out of both of those terms? Yeah, only 1, right? That's the trickiest part, is like trying to convince yourself that you can factor out by 1, right? Even though it does nothing really, but for grouping, it's essential. So we can factor out a 1, positive 1, and by doing so, we're left with the same original term, 4a minus 3. So now, new GCF, right? They both have the term 4a minus 3. So we factored that out from both of them. And we have some leftovers, right? Leftover and leftover. 3a squared plus 1. Okay, not too bad. Questions on number 4? All right. Cool. Okay. Let's get to number 5. Go ahead and copy this one down. Think about what your strategy would be. What do you think is a good place to start? Ooh, GCF, I like it. What do they all have in common that they could all be divided by? Yeah, they all have the 2, right? They all have the 2. So we're going to go ahead and do that first. Factor out a 2 from every term. 24 divided by 2, 12. X to the third. 12 divided by 2, 6x squared. Negative 28x divided by 2 would be negative 14x. And 14 divided by 2 is positive 7. All right, so we factor out a 2. All right, that's good because that's going to help simplify things a little bit later. And I still have a 4-term polynomial, right? So for now, I'm going to kind of ignore the 2, right? It's kind of done its job for now. Now I can work directly with whatever is inside my parentheses because that's still a 4-term polynomial. So I need to apply grouping factoring to this. All right, let's try splitting it. Okay, so we're going to bring down the 2 after eventually, don't worry. But for now, if I'm just focusing on what is the GCF of those first 2 terms, what would that be? Yeah, 6x squared. And what's left over? Yeah, there's a 2x minus, 1, right? 6x squared over 6x squared is just 1. Okay, now take a look at negative 14x plus 7. All right, who's the leading term? Negative 14, that's right. Oops. So then what could be the GCF there for those last 2 terms? Yeah, we want negative 7, right? That's my GCF, which leaves us with what inside the parentheses? There you go, right? 2x minus 1. All right. Here's a common mistake. Let me just show you. A lot of times what happens is this. We forget about the leading term, right? That if it's negative, we want to factor out a negative. Here's how you check yourself as you go through the process. Let's say you forget about the negative, right? You only factored out 7. What would have been left? Negative 2x plus 1. Are these the same? No, right? So at this point, when you get to this part and you realize like, oh, wait, those are not the same, that means I've maybe made a mistake, right? You see the checking process for yourself. So that's how we know that, yep, we were supposed to have factored out a negative 7 because that turns this into a positive 2x and this into a negative 1. And now they do match 2x minus 1 and 2x minus 1, correct? All right. We'll worry about the 2 at the end. Let's just try to factor what we have in green, right? We have a new GCF. What is that new GCF? Right, we can see it's 2x minus 1. So we factor that out of both of them. And I have some leftovers. 6x squared and minus 7. So those are going to go into my new term. Okay. But would it be correct if I left it like this? Not quite, right? Because what are we missing? Yeah, we need to bring down that 2, right? The 2 is still part of the polynomial. It's just that we factored it out. We left it up there until we could focus on cleaning up the 4-term polynomial. And now we should bring it back. Okay, this would then represent the equivalent expression for the original polynomial. And now we're done. Any questions there? All right, cool. Number 6. Feels easy, right? I hope this feels easy. All right, let's try a box. See how this goes. All right, let's make a box. So order matters a little bit more with the box when you're doing a grouping. 4 terms, just go in order. 3x to the third, 5x squared, negative 27x, negative 45. All right, so it's like 1, 2, 3, 4. All right, let's GCF. First row, what can I factor out? Yeah, just x squared, right? Because 3 and 5 only have 1 in common. So x squared. Negative 27 and negative 45. What is the GCF between those terms? Oh, think bigger. Yeah, negative 9, right? Negative 9. 9 divides 27, 9 divides 45. And since negative 27 is your leading term, we factor out a negative. Okay. All right. First column, 3x to the third, negative 27x. What is the GCF there? Yeah, 3x, right? So 3 divides both terms, and they both have at least x in common. What about the 5x squared and the negative 45? Negative 5, you sure? What's the leading term? Oh, but the hold on. 5 5x squared would be your leading term. Negative 45 is your constant. Right, so typically the term on the top is your leading. All right, so that's your leading. So we could just do a positive 5. They don't have x in common, so it's just 5. All right, so my two factors are 3x, and then that 5 is positive, so 3x plus 5, and x squared minus 9. Guess what I'm going to ask next? Is there something there that could be factored even further? No? It's breaking my heart. I have failed you. Just tell you, no. Mm-mm. We covered it last time. Not last time, but like first quiz. Mm-mm. I'll give you a hint. It's the second factor. What do you call that? Give me the name. Nope, not the lead. Give you another hint. What do we call that? What do we call the types of polynomials that are x squared minus 9? Yeah, something with a square, right? Give me the name. Give me the name of that type of polynomial. It's a special type. Cubed would be powers of 3. Do you see a power of 3? Trinomial is when it has 3 terms. It is a binomial. It's a special binomial. Somebody said it in the direct chat. I want you to put it on the full group chat. Yeah, it's a difference of squares. Yes, good. I know we did it before spring break, but right, that's one of the big ones. It's one of the easier ones too. All right. So the difference of squares, you always have to be on the lookout because sometimes some polynomials can be factored even further. All right. You always have to kind of do that visual check to see whatever I got, can that be factored one step further? Okay. And we call that factoring completely. So you have to start going back into like, further memory to remember like, okay, that looks familiar. I should be able to factor that because you'll be expected to factor it. So what are those perfect squares? Well, x squared is a perfect square because we can get it from x times x. How do we get 9? Perfect square, 3 times 3. Right, so remember that this will factor into x plus 3, one positive, the other one negative, x minus 3. And we need to also bring down the other factor, 3x plus 5. Now I have a fully factored polynomial because I've taken the difference of squares and I've factored it. Okay. Questions? I know you guys knew. Maybe you just forgot because it's been a couple weeks. All right, but now that you see it, you got to keep an eye out for it. Okay. All right. Let's move on. Yes. Yeah, mark it. Give it a star or something. All right. Something to help you remember. Okay. Next one. Here we go. All right. I like these. Example 7. All right. This one is also a special case. All right. This is a different star though. It's for a different reason. All right. Let's go traditional. All right. Let's go traditional. Let's split this up. 40 and 21. Is there a GCF there between 40 and 21? Are those first 2 terms? Yeah, just one, right? So imagine, all right, you begin the process and you say, well, there's nothing there. So we factor out a 1. That means you're left with 40xy minus 21. Next 2 factors or next 2 terms, negative 56x plus 15y. Is there a GCF there? Yeah, maybe just negative 1, right? 15 is divisible by 5 and 3 only. 56, 23, no, not 23, 28, 7, 8, right? Doesn't look like they have common factors either, right? So we factor out a negative 1 and you're just left with positive 56x minus 15y. All right, what's the problem? Can you move forward? Yeah, we can't move forward because whatever is inside the parentheses is not the same, right? There is no new GCF here. So we're kind of stuck. Any ideas on what we could probably do? Kind of take a step back, right? Obviously this didn't work, but is there something else we could do that perhaps could allow us to move forward? You have to be a little creative here. Sort the equations. Explain more. What do you mean by that? Okay, so do you mean sort as in like rearrange? Okay, so having a, okay, someone said switch the negative 56 with the negative 21. Okay, let's do that. Right, at least if like, let's say if we brought negative 56 to the front to match it with 40xy, at least they have x in common, right? At least they have that. And then maybe we'll find another GCF between the second two terms. So on a problem like this, when you first do that first round of GCF in the two groups and you notice that they don't have something in common, that means that you probably have to rearrange the terms. All right, that's also a common thing that happens in grouping. It's like, okay, the terms are just shuffled around incorrectly. We have to move them around. So somebody mentioned, let's suggest it. Let's switch 56x, negative 56x with negative 21. All right, if we do that, just be aware, right? You're moving negative 56 and negative 21. So keep those negatives with that number. So I'm just going to rewrite it as 40xy. So we rewrite 40xy minus 56x. And you want to swap it, right? So you have now negative 21 plus 15y, right? So you see, we just rearranged the terms. This is, you are allowed to do this. You are allowed to rearrange terms when they're not arranged in a way that lets you move forward. Okay, so now let's try it. Split it into two groups. What is the GCF of the first two terms? All right, we have 8x. All right, we have something good. 8x, what's left over? Okay, we have 5y minus 7. Okay, good. All right, you take a look at the next two terms. What could you factor out of those two? All right. If I'm thinking of 21 as my leading term, then I should probably factor out a negative. So if I factor out a negative 3, what's left over? Okay, 7 minus 5y. All right, now what's the problem here? Are these the same? Is 5y minus 7 the same as 7 minus 5y? They're not the same. Is there something we could do to kind of fix that? If we kind of go back a little bit, is there something we could do to fix that? Should we have left it as negative 21 plus 15y? Yeah, maybe we should have rearranged it, right? Notice how negative 21 is the constant. The constant usually should go at the very end of the polynomial, right? It really has no business being in the middle where all the variables should be. So let's just rearrange that real quick. All right, so I'm actually going to rewrite this one as 15y, right? Positive 15y minus 21. So what we did is we just actually moved negative 21 to the very back. All right, now let's try to factor out that 3, right? Because now 15y is my leading term. I don't need to factor out the negative anymore. So factor out the 3. Let me just give us some space. Factor out a positive 3. We're left with 5y minus 7. All right, so a little bit of rearrangement is what we needed to do for this one in order to be able to get a good, GCF out of it. All right, but we can see now, hey, they do match. 5y minus 7 and 5y minus 7. So now that's my new GCF. And my leftovers are 8x and positive 3. So 8x plus 3 is my new term. Before I box, look at the two factors. Can those be factored any further? Is there a difference of squares? Is there a cube? Some are difference in cube. No, right? All right, so we're good, right? So now you know when you get to the end, always ask yourself, could I factor this one more time? All right. And since the answer is no, we're going to box it. Okay. And then the last one, example 8, very similar to example 7, right? We're gonna have to do a little bit of rearrangement. So let's move on over here. All right, but it's a little more challenging because there's no actual just constant, right? There's multiple variables, x, u. All right, this is a u, by the way. It has a little tail. These are u's. These are v's. Okay, the greens are v's. The blues are u's. I put a little tail on my u to make it different from the v. So you could rearrange it from the start. Yeah, if you kind of preview ahead and you realize like, hey, these GCFs are not going to give me the same term inside the parentheses, you could begin by rearranging, right? If you can kind of do mental steps ahead, you can, all right? Is there one in mind that you have? Is there a rearrangement, particular rearrangement you would like to have that probably works better than what is currently here? You want to swap out the negative 108 YV for 24 YU. Okay, we can try that. So you want to bring this one and swap it with this one, is what you're saying. All right, notice, I'm glad you said the negative 108, right? So I bubbled the negative 108 because that negative is crucial. It has to stick with the number when you move it over. So let's try it. Let's try this rearrangement. We have 2XU. If we swap it with the 24YU, then we would have minus 9xv squared minus 108 yv squared. All right. So from here, let's see if we can get something from this. After the second term, what is the GCF there between the first two terms? You respectfully disagree? Okay. All right. Well, let's see if this works. If it doesn't work, we can try another method. Let's just try it. Let's see how it goes. The variables won't match. I don't know. Let's try it. I think it will. I think it'll be fine. What's the GCF of the first two terms? Let's start with that. What do they both have in common? Okay, we can factor out 2u. If we factor out 2u, what's left over? X and 12y. Okay, so x plus 12y. Okay. All right, now take a look at the next two terms. What can be factored out of those two terms? Okay, right, leading term, -9. And they both can be divided by 9, right? So -9 v squared, they both share v to the power of 2. So what's left over? Oh, you take it back, you agree. Okay. All right, so what's left? We divide -9xv squared by -9v squared. We're left with x. We divide -108 by -9. That should give us a positive 12. And the v squared divided by v squared should cancel, so we're left with just y. Okay, how does that look? Pretty good, right? The goal was let's get the same term inside the parentheses. Make sure that those match. So we have x plus 12y. That looks good. All right. So good intuition in order to do that rearrangement. All right. So now we can see, hey, x plus 12y is my new GCF. And then my second term should be my leftovers. So 2u minus 9v squared. All right. Final question always is, can it be factored any further? All right, I agree. It cannot. Right, it's close, but it's not quite a difference of squares, and there is no other GCF. The negative 9v squared is a perfect square, but the 2u is not a perfect square. So this one is not a perfect square, and there's nothing else we can really do to factor. So here it is. So all right, this one was another one, kind of a special case. We had to rewrite or rearrange. Let's see.